Okay, good afternoon everybody. Welcome to our virtual open day on the MSc Spatio-Temporal Analytics and Big Data Mining. So hopefully you're here because you're interested in studying our course next year. So we're going to try and answer some of the questions you have about the course and give a quick overview. So to begin, just to explain how this works, we're going to talk, myself and Professor Prof Cheng is also here, we're going to talk for about 20 to 30 minutes about the course. And then while we're doing that, we'll be recording this so that we can share it with you afterwards. And then we'll stop the recording at the end of the 20 to 30 minutes and we'll open the chat rooms for you to ask us questions. We find it's easier for you to type the questions in and we can answer them by the text. Then we've got a record of the answers to those questions which we can share with you afterwards, just in case you miss anything. So who is here today? My name is Dr James Haworth. I'm one of the lecturers on the course. I'll be teaching 2 of the modules that you learn. And I'll talk about those a bit later on. Also here, let me just say hello as Professor Prof Cheng. So,
hello everyone. Welcome.
So I'll pass over to Professor Cheng for some of the talk a bit later on. And also here we have Emma Whitney, who is our Communications and Marketing Manager. So between us, we should hopefully be able to answer all of the questions you have about the course, but obviously we're available on email if there's anything else you don't think of today. Okay, so just a brief overview of the talk. So we're going to start with why study at UCL. You'll be joining a huge institution, so it's useful to know a bit about that. Then we'll talk about, I'll pass over to Professor Cheng to talk a bit about what spatio-temporal analytics is and why it's important to study this subject. Then I'll go through some of the details of the program, so the modules that you'll learn, the dissertation, and the various other activities that we run throughout the year, and then some administrative details like the entry requirements and obviously the fees, which I'm sure you'll be very interested in. And then after that, as I said, we'll pass over to you and you can ask any questions you like about the course. Okay, so why study at UCL? If you're applying for UCL, you probably already know that it's a globally world-leading university. So in the latest QS World Rankings, we were ranked number 10. We're located in central London. Last year, London was ranked the best in the world for students. It's a great place to live, great place to work. This picture here is the portico of UCL. It's a very historic campus located right in the heart of the centre of London. So if you look at the Visit London guide there, UCL is located right in the middle of all the main tourist destinations. So it's a great place to study for a year, great places to eat, great nightlife. So I'm sure you'll really enjoy your experience here. But you're mainly interested in studying, of course, so I'm going to now pass over to Professor Prof Cheng, who's going to explain a little bit about what spatio-temporal analytics is and give you an insight into some of the research we do in the department.
Hello, I'm Carl. So I hope when you join this virtual open day, you might got some idea about why you want to do this course. Of course, I mean, I don't know your background, but we have students come from all backgrounds: geography, computer science, psychology, architecture, ecology, environment, and natural hazards. Okay, I think one of the things all of us together is about the data. So what the data really special about it is because the data are geolocated and time-stamped. Even like you travel in London, you use Oyster card with your smart card data. You can use the bank card to pay for it. Even that, we know where you are, that's the station, and also we record the time of your passing the station. So that's what's the spatial about. The spatial and temporal is about the location and time. Okay? So what is special about it? It's just data, right? But what's the difference between spatial temporal analytics with normal big data analytics? Because spatial, sometimes they call it spatial because the location. So the many ways, many tools you will learn in the class, like conventional regression analysis, which are not that suitable for what we call the spatial data. The location make it special. In a more specific term, we call heterogeneity or non-stationarity. That means something you find in one place unless really can be applied in another place. So that's a little bit special. Of course, we use more specific term. I talk about data is dynamic, and also that the dynamic means say not only in time and also in place. So of course, big data is big volume, right? When we talk about spatial, sometimes we link up to human behaviors as well. So there's lots of challenge around it. So in a way, what is spatial analytics, spatial-temporal analytics? We define ourselves which somehow between computer science, geography, or engineering, right in between. Okay, so if you want to say computer science, and this is pure computer science, geography, GI science, we are right in the middle, spatial-temporal analytics. So that means I'm exactly you have very good background, quantitative skills, and also know something about computer science. So you will be good in programming or good in math. Of course, we also welcome the students which have, as I said, all the broad specific discipline or domains. So in the following few slides, I want to give you a little bit of flavor of the things what we do here, and also that's what I hope. When you finish our course, you are able to do it. That's the skills you're going to have. So you're going out to say, yeah, I can do this. Okay. Unfortunately, we can't really show live video on this podcast, but this what you see is a static screen capture. So what I show on the left one is called James Lamb is there, and that's something he did, and you need a PhD study. So we call it data-driven traffic prediction. So what it does, so basically in Google, you use Google Maps, Google tell you how long you will travel from A to B. So what James is doing is trying to predict how long it takes from one point to another point. But what's the difficulty in this one? Because there's lots of missing data. So when we use, no matter use GPS camera or manual cut, sometimes you will have missing data. When data is missing, it's very difficult to use models. So James provides a methodology, which is the machine learning approach, to develop a model which is able to predict the traffic. And more than that, more difficult thing when you try to predict what we call the peak time. So more congested situation, how you deal with it. So he quite clear. So that's James. So James you will see him a lot if you come here. Another one on the right is called the work done by Dr. Adam Manning. He's also now senior lecturer in CASA in UCL. So what we did here, basically, if you look at this side, so this is Regent's Park, this is the Hyder Park, okay? So this UCL is somewhere here, okay? So this is a road called the Euston Road. This road, King's Cross is here. If you want to go to Europe, you use King's Cross to go to Europe. So what do we do this one is basically, as I said, unfortunately we can't show the simulation. It's really fantastic to tell you, say, we can use what we call real or region distillation to simulate the driver's behavior. So from that, we can really understand how the traffic is accumulated on the road. So in the simulation, you can see the Eastern Road getting very congested. So that's kind of something we're going to learn in this course. So there's two examples in transport. And one more thing I know, everyone talks about the machine learning and AI. The most advanced technology is deep learning, right? So in our lab, Zhang Yang is a PhD student. She developed what they call the latest, most cutting edge deep learning methodology. And only dealing with the image, but really to predict the traffic and road network. If you learn a little bit about deep learning, most people do deep learning is on image. So, but we bring them to the network because anything related to urban life is happening on networks. So most of the work in our lab is on networks. So the next one is something about business intelligence. That means we're dealing with all the data relevant to consumers. So this just give you a very simple example. I don't know how many people you treat. This example of another PhD student, he makes use of the Twitter data to analyze people's interest around the public place. In this case, is a tube station. So what's useful? So that means if we know people's major interest at a particular place, at a particular time, we talk about space and time, so we can really make the advertisement more specific. So at this moment, I think you are talking you are listening to my talk, maybe in about 2 hours' time. Of course, in London time, I'm talking about, we're more interested in where to go for drinks or where to go for restaurant or go to live shows, okay? So that's the useful for this. So what we need to say is not necessary, just put your advertisement just for more people. You got to make the topic relevant to the people at that time. So the next one is slow. Yes, this one is another thing, very exciting thing, is our working together with Metropolitan Police, London. So again, for machine learning, for data analytics, multiple analysis, we said is run what we call images is grid-based or regions. So this is what we call it a little bit more abstract or macro. But what we want to do is basically we want to put the crime hotspot on network. Again, network is the fundamental spatial unit for city. So for policemen, they're working on network, they patrol on network. So we want to make the prediction really precise and easy to interpret a network. So that's also the latest crime hotspot prediction produced in our lab. So the final one I want to show you is another area about electric hazard. As you know, there's recently lots of big demonstration in London about this environment or the pollution, you will say gas pollution or CO2 emission. So it's part of this. So this one I'm showing you is about landslide. This is the case in South Italy. So make use of existing landslide data. Use one of the machine learning techniques called random forest, which you're going to learn in the course, to kind of mapping out the most vulnerable areas, which is highlighted in this map, which is going to be more vulnerable for landslides. More than that, we also map out the types of landslides, which is a different color to show them. The reason for that is different type of landslides, when it happened, you may need different ways to respond to it. So we also map out which roads going to be more vulnerable for those landslides. So what's the use for that? After you're able to map out where is landslides, what type of landslides would be, and which road or other key infrastructure like a bridge or tunnels will be impacted. Then we also map out the delay of the transport or delay of traffic, and we can also map out the economic loss. So it's kind of a cascading effect. Landslide happened triggered by bad weather, you may say, and then the important key infrastructure, then the people's life, then on the economic loss. I hope this can give you some flavor about all the things you're going to do and going to learn in this course. So, of course, we have many more. We do lots of other things. Even we have students working on economics, financial data set. I think that's the main for examples. Oh yeah, of course, this is, I hope give you enough information about the analytical skills you have, but we also want to train you to tell the story. So talk about visualization. So this is just showing you some traffic congestion in London, but we use what we call a 3D wall map. Why you put a wall map, you can see it's just like a wall, static, up. So basically this is showing, say, is about, I think it's for 12 hours. So from the 6 o'clock to the 6 o'clock in the morning, from the bottom to 6 p.m. in the evening. So this really shows, say, in the central of London, this is the area. You can see the congestion. They started in early morning quite early and then last to quite late in the evening in the town center. This is also shows 2 days. This is a day on the right. Have a day that we have a tube strike. So you can see the congestion is much worse on the road surface. So lots of people driving car to the office, which they normally don't do on the normal day, but they start driving the car, so the traffic is getting much more congested, which shows in the red color, of course. And the final one, I was trying to show you another thing about the visualization. On the left is about 300 policemen's GPS trajectory but we visualize them into 3D space and time, the 2D space and one-dimensional vertical is the time. So it's 24 hours, but it's 2 months later. So what we do from that is raw data, but then actually we can do lots of sophisticated analysis, which we call a spatio-temporal DB scan, density scanning. So we can really capture the concentrated, what we call the spatio-temporal region of interest. So this is showing you around this, which is like a cylinder. So you can see with this particular period of time and in this particular location, those group of people are concentrated. So in this, we can really interpret from raw GPS data to something more meaningful. Based on this, the region of interest people observed, actually we can further analyzing the behavior of the people. So that's the part of the most space-time analytics. Okay, I hope you give you examples. Now I'm going to bring back to James to finish more overview of the program.
Thanks, Tel. Hi, everyone. So I'm just going to run through the structure of the program and a few other administrative details. And then if you have questions about those, you can ask us after. So just to give an overview, so our aims, we aim to train you in the theory, tools, and techniques of spatio-temporal analytics. So in particular, the tools are quite important. So we will teach you the technical skills you need to work with big data, as well as the theory behind those tools. So you should develop an understanding of the way in which you should work with these data, plus the applied knowledge that you can then take forward either into a research degree or into a professional degree. So the third aim there, you can see we really want to equip you for a career, and our graduates are very employable. We plan to have a student in this meeting, but he's unfortunately had to go to a job interview, so that kind of tells you the position that our students are in. So in terms of modes of delivery, we have a combination of lectures, computer labs, and seminars. A standard module will work with 2 hours of lectures per week, followed by 2 hours of computer sessions. That depends on the module, but generally that's the way it works. So about 50% you'll be working on your technical skills. In terms of assessment, we have a range of group coursework, a couple of exams. It is possible to choose a selection of modules and only have one exam, depending on your interests. But we have lots of coursework, either individual or group, and we do work on your presentation skills as well. So we use a range of software. So probably if you're coming from a computer science background, you'll be used to different programming languages. So we focus on Python and R programming language. If you choose Web and Mobile GIS, then you'll look at web development languages. If you haven't come from a geospatial background, you might not have heard of some of the proprietary software that we use. So we use things like ArcGIS. If you choose certain modules, you may use things like FME and Revit. That depends on your choices. And we also use a range of open source software. So we use database software, QGIS, which is another geospatial software. All of the software is available free to you while you're here. Where possible, we tend to use open source software so that when you leave, you're able to still apply the skills that you've learned. We have quite strong careers development aspects of the course. So we run seminars throughout the year where we invite research speakers and also industrial speakers, many of whom are former students of our MSc courses. So you're based in the Civil Environmental and Geomatic Engineering department, and we have a number of degrees here. So we have this degree, and we also have Geospatial Sciences degrees, and you'll share your careers development events with them. So you'll get access to a range of other things, not just suited for you. So it's really quite broad there. We'll run a range of events, so we may have things like mock interviews and CV reviews. That depends on the way in which the year develops. And obviously, being in a central London location, we're ideally situated to join a range of seminars and events that go on. So we have a series of events called Geo Plus Data that's held at UCL, where we have one industrial and one research speaker. Those are always oversubscribed, but we will open up the entries to you guys first for those, and various other things like the Royal Geographical Society. In terms of the program structure, so it's 4 modules per term. Each one is 15 credits. In the first term, we have geospatial science, which gives you a foundation in the kind of geospatial side of things. So things like datums, map projections, ways of collecting spatial and temporal data. That's in case you come from a background that's more on the computer science side, that's designed to bring you up to speed with the geospatial side. In terms of spatial analysis and geocomputation, I teach that module. Here we'll talk about, it will give you a grounding in spatial statistics and spatial analysis techniques. So a lot of the properties of spatial data that Tao talked about earlier will give you that basis in these, and this will provide the groundwork for the second term modules where you focus more on the spatial temporal aspect. Databases and data management, obviously we're dealing with large data sets with a spatial aspect to them, so you need to understand how to deal with databases that can work with that type of data. And then finally, geospatial programming is starting from an introductory level, but with quite a steep learning curve, learning Python to work with geospatial data. So it's a programming module, but it's also specific to working with geospatial data. So that's the first term. There is also an option on discussion with Tao as program director if you want to swap out one of those modules for an elective module, but that's something that you can discuss when you're here. So term 2, again, selecting 4 modules in total. We have 1 compulsory module, so that's spatial temporal analysis and data mining. So that module follows along from spatial analysis and geocomputation. So building on the basic statistical techniques that you learn in the first term, we move on to dealing with the properties of spatial temporal data as opposed to just spatial data, and also looking at machine learning techniques there. So you'll learn things like kernel-based methods, neural networks, clustering methods, all for dealing with spatial temporal data. The remainder of the modules you can choose from depending on your interests. So, for example, web and mobile apps and programming, if you're interested in web development, then that's a really interesting one for developing location-based apps. Mining social and geographic data sets, that's a module from geography that looks at dealing with network data and social media data and things like that. Applied machine learning, if you really have a strong computer science background, then you may choose to study applied machine learning, which is a module from the computer science department, master's level machine learning module. So very, very technical, but very rewarding if you're that way inclined. And finally, urban simulation is looking at how we can use simulation techniques to model urban processes. So that's based in the Centre for Advanced Spatial Analysis. So you can see that our diet in the second term is quite varied and does allow you to go in a range of different directions. Beyond this, we also do allow you to exchange one module for an elective module, provided that it's a relevant module. So from throughout the university, if you find something that's relevant to the skills you want to learn, then you can have a chat with Professor Cheng, and we can arrange for you to take that module, subject to there being space. So in the third term, from May to September, you'll do a dissertation. Our dissertations, there's a range of options to choose from. So generally the way it works is that your research will be linked to a supervisor. So your research could be linked to an academic project that one of our academics is doing. So for example, with myself, you might be working with bicycle data because I'm interested in that. With Professor Cheng, you might be working with crime data in relation to the projects she was talking about earlier. We also have a range of industrial projects with industrial partners. So I would say around about half of our students each year do an industrially linked project where you may get the chance to work in the offices of a business. We have links also with the Consumer Data Research Centre in Geography, who run a program where they offer dissertations linked to retail partners. So plenty of opportunities to engage with industry when it comes to doing a dissertation. The project is 10 to 12,000 words in length, and you will end up producing a report and a poster like this one here towards the end of your degree. Okay, so in terms of entry requirements, what do you need to come here? Tao mentioned already that it's quite a technical course, so we expect you to have a 2-1 or equivalent. admissions team will be able to advise you on whether your degree meets the requirements. If you don't have a 2-1 equivalent, then you can apply if you have relevant work experience. So generally we look at around 2 years relevant work experience, and we judge that on a case-by-case basis. If you're worried about whether or not you meet the requirements, then send Tara an email and we can advise you on that. As is the case with all degrees at UCL, if English is not your first language, then you have to meet our language requirements. I mentioned again that it's a technical degree, so we do have a sheet of preparatory materials which we send out to all students preparing to do a geomatics degree, so either geospatial sciences or this degree. So there's a few things on there. You don't have to do all of them if you feel like you've already got that background. But if, for example, you haven't done any programming before, if you can cope with the material that we pass out on this list, then you should be able to cope with the start of the course in programming. So we'll circulate those to you in due course, and you can have a look through those. Most people we find who apply to this degree have got the necessary technical skills to start the course, but it is worth making sure that you've brushed up on those. So finally, fees. So full-time fees, if you're a UK or EU student, it's £12,750, and if you're overseas, it's £26,660, and the part-time fees are roughly half of those, but all of the details are on the prospectus website. And it's worth noting, if you are a UK or a student from England, then you can apply for a loan to support your MSc study these days. Okay, so by being here, you've probably already seen our page, but do have a look at that. You can also find various other information on our CEGE page about other courses. So that is going to bring that to an end now. I'm just going to pass over to Professor Cheng for some closing remarks.
I think James has already given you lots of the details of the course. I want to emphasize or summarize the main points. Say, if you want to choose this course, so what makes our course different from any other course in the whole world? Okay. So number one, I think James mentioned about the summer project. So some project, as James already said, half of the program actually, the project is directly come from the industry. You have direct industrial supervisor with academic supervisor. So I think after that, maybe half of them go to directly work with the company. So that means to say the chance of a job is really, really high. So that's one. And second one, the program is kind of say very diverse background, and even especially in my course, actually with each 5 or 6 programs, the student choose my module on spatial-temporal data mining. So some from computer science, some from spatial analysis, geography, architecture, finance, politics. So what's advantage of that really give you the exposure of the dimension of other discipline and really inspire you when you look at the program differently. I think that's really good. And the third one is about, we have a weekly seminar. Actually, this seminar, some is from the industry, some is from academics. So what is that? Basically, this also same thing, give you good exposure to the industry to enhance your job opportunity. To, if you want to go to join the company, but equally, we also have tons of all the leading academics come to UCL, give a talk like today. I'm a top professor in China in visualization, just gave a talk in our lab. And the first one is about the optional course. Basically, as we listed the course on the website, we have quite some. This actually is mixed with our own department, the class and the geography. So already 4 departments and the computer science. So it's a 4 departments course. But in UCL, if you really have some subject you're really interested in, which is not on our standard program, you can discuss with me, and we discuss with other department. If they think you are suitable, is suitable for you, and also you qualify to take it, you can have the chance to take it. So the final point I think is most important. What really make this, not talk about what generic about our MSc program, but really come to this course. what make this course different is the technical bit, the technical bit about dealing with space and time, right? Why is it important? And I think you already know the answer. Basically, if you look at all the big companies, Google, Amazon, in China, Huawei, or Alibaba, or Baidu, or Tencent, who actually really recognize most urgently needed talents in this company is someone able to dealing with spatial temporal data. Actually, last year, I think, I don't know if you look at know anyone in the program, I think the year before last, I only got people less than 10 people, and last year we got about nearly 20 people. So that means there's a demand there, and I think that's probably why you're interested in this course. I think I just want to summarize it. Okay? So now I think we come to the Q&A question session. Yeah, about Dr. James.
So I'm just going to turn off the webcam now, and we're going to pass over to you. So if you start typing your questions into the chat box, then we will answer those directly in there, and we'll share a transcript of the conversation once we've closed up at about 4 p.m. Thank you, everybody.